We're going over transformations of logs, and just like exponentials, we're going to only kind of cover vertical and horizontal shifts. And these are the same as any other function that we're shifting from module 2 or exponentials. When I have a log, and I put in here common logs and natural logs, but it can be a log of any base, right? If you add k, you add something to the end of it, it's going to shift it up. If you subtract k, those are going to be shifted down. So vertical shifts are predictable. Plus means up, minus means down, and these happens when they are outside of the log. When you have horizontal shifts, now you are adding or subtracting something within that log. And so you're going to see your parentheses to group it in, to include it in that log. And these go opposite of the way we think. Plus is actually going to be to the left, minus will be to the right. So pause that if you need more time to write those down. And we are starting here in example 4. Now, a little side note, if you're using Desmos to get that subscript, which is what that 5 would be, you're going to hit your shift key and then your minus key. So on your keyboard here, you'll hit your shift key and then like your minus button right here. And that's how you need that subscript. So if you are taking this class on campus, that'd be a good note card thing to write down. All right. Example 4 says, for the following function, briefly describe how the graph can be obtained from the graph of a basic log, and then graph the function, state the domain, and the vertical asymptote. So first, you need to identify what the base is. Well, this is log base 5. And what is the horizontal and or vertical shift? So we have parentheses with that x plus 3. So we know it's a horizontal shift. And because it's a plus, that's a plus h, it's going to the left. So this is left 3. Okay, now I have these little asterisks here again, because when you are in my math lab, all you need to be able to do to graph is be able to state these two. So let me show you. I have one pulled up here. You have to put in the shift already. Once you put in the shift, you're going to click in the graph and you're going to click your log tool. So if you don't know which one's which, hover. If you hover over this one, it's your exponential tool. So if you hover over this one, log. And this is the exact same way as that exponential was. Hover anywhere in this graph, click anywhere. It's going to put it where it wants. I think it always puts the base in here, but make sure you have the right base. And then we're not shrinking and stretching in any direction. We're not reflecting anything. So you are just moving it down or up or left or right. And so this one you go right 2 units. Okay. So that's all you need to be able to do to graph these. What is the domain? That's what we did in the last video. You take what is in your parentheses, what is inside the log, and set it to be greater than 0. Remember, it cannot equal 0 because that's where you have a vertical asymptote. So here, subtract that over, and we get that x must be greater than -3. So I don't know how they want you to write this. It might be this, or I'm going to assume that they want this in interval notation. So that will be -3 to infinity. And so where is the vertical asymptote? The vertical asymptote is always where this domain starts. So we have a vertical asymptote at x equals -3. So easy enough. Now, if you want, you can bring up Desmos to find that. So here is my function. And again, to get that subscript, shift and the minus key. And you can see here, excuse me, that as we go down, that's getting closer and closer to -3. And then once it eventually gets at -3, it just like stops sliding and it says it's undefined. So that's where your asymptote is. That's where your domain starts. Okay, 5 is the exact same thing. Go ahead, pause the video and see if you can answer this one on your own. This is your last chance to pause the video if you want a chance to do this on your own. So first thing it asks is, where is the base at? Or what is the base? And this is a common law, right? If we don't see a base, then there is a known 10 to be right there. So this is a base of 10. What is the horizontal and or vertical shift? So this -2 inside parentheses shifts it to the right. And then this 3 on the outside, that plus K, moves it up. So this one is right 2, up 3. What is the domain? So hopefully this one wasn't tricky, but when you're finding the domain, all you care about is what's inside that log, what's inside the parentheses. So we are setting x -2 greater than 0, again, not or equals 2. Add that over and we would have got x equals 2, or sorry, x is greater than 2, or 2 to infinity. These two things mean the same thing. And then where's the vertical asymptote at? The vertical asymptote is right there at x equals 2. Whatever this starts is where that vertical asymptote is. And if we pull up Desmos one more time, here is my log. And you can see here, it stops right there at that undefined at 2. So that's where your vertical asymptote is.